move into the next part, which involves the same polynomial long division, but we might have remainders. So here is on exercise 5, and we're on page 22. Here is our example with numbers, and because we've already kind of talked about the long division, I'm going to go a little more quickly. So 9 goes into 40 4 times, which gives me a 36, and I subtract. So here I have 4, bring down the 7. 9 goes into 47 5 times. 9 times 5 is 45, giving me 20, and then bring down the 3 when I subtract. 9 goes into 23 twice. This is 18, and I have a remainder of 5. Now, probably the trickiest part of this, once we get to the variables and the polynomials, is knowing how to write that remainder. So basically, 9 goes into 4,073 452 times with a remainder of 5, which means that we have 5 ninths at the end. Okay, so there are 5 out of 9. We didn't quite make it to 453, so we have a fraction left at the end. Moving down to the next one, looking at that same concept with polynomials, the division is going to look exactly the same. You're going to see some weird directions sometimes. Sometimes you just have to find out you have a remainder, but on Delta Math at least, it's going to say if there is a remainder, express the result in the form q of x plus r of x over b of x. So this q of x is just saying that there's a quotient that's going to be the function. So in the above directions, q of x is the quotient or main part of the answer. So that's like what we've been getting on all the other ones. R of x is a function that's the remainder. So whatever the remainder is, so in this case, R of x would have been 5, Q of x would have been 452, and B of x is the divisor, or what we're dividing by. So in this case, this would have been Q of x, R of x, and then this number we were dividing by is B of x. So they gave them function names. It's kind of confusing, but getting used to the directions and knowing what to do is important. So the only difference here is instead of writing this as a mixed number with the fraction right next to the number, we're going to have to put an addition sign in because otherwise it kind of looks like we're multiplying the quotient by that fraction, but we're really adding on that fraction. So starting out in the problem, as I said, everything is going to be really similar to what we did before, but at the end, it's not going to divide evenly. So we're putting x minus 4 into that polynomial. X goes into 4x cubed, and always, just like I did before, I'm not going to do this every time. So 1x. I can write that division on the side if you really need it. So this equals 4x squared. So that's 4x squared times, and then we'll multiply it out. So multiplying this out, 4x cubed minus 16x squared. Subtracting. Changing the signs. Cancels. Negative 18 plus 16 is negative 2x squared. And we'll bring down our negative x. So now we're saying how many times does this 1x go into the negative 2x squared? That's negative 2x times. And then we'll multiply this by the negative 2x. So that's negative 2x squared. Negative 4 times negative 2x is positive 8x. And we'll subtract and change the signs. Okay, cancels. Negative 1x minus 8x is negative 9x. Bring down the 27. So now our 1x goes into our negative 9x, negative 9 times. 1 times negative 9 is negative 9x. Negative 4 times negative 9 is positive 36. So from here, my negative 9x's are going to cancel. We'll change the sign. 27 minus 36 is negative 9. And yes, when we do polynomial long division, you can get negative remainder. So this is remainder negative 9. So to write it in that form, q of x plus r of x over b of x, my answer, and this looks like the most space I have to write my answer, is 4x squared, this is my quotient, minus 2x minus 9, plus my remainder is negative 9 over my divisor is x minus 4. So that is my answer. Now, I could have taken this negative sign and written this as minus 9 over x minus 4, like that negative sign right here could move down to here. Either way is fine if you thought about that. So let's try one on the next page. And I know yours was kind of split up and messed up, as I said, I'm sorry about these pages. So now we're on exercise 7. If you want to pause the video and try this one and come back, but there is something a little different here. It's not a big extension, but now I'm going to divide by a trinomial. Not really any different, just the multiplication will take a little longer. So this one, we're dividing 9x to the 4th minus 21x cubed plus 12x squared minus 26x minus 18. And I kind of equate this to when you're in like 2nd grade and you start to learn some math, you're like, wow, when I get to high school, I'm going to be multiplying like 10-digit numbers together. And that's not really true. Like nothing really would change. You learn different math, but even though these polynomials are bigger in terms of their exponents, the process is still exactly the same. So we are still only looking at the first term. So we're saying how many times does 3x squared go in 9x to the 4th? So I could write that on the side just like usual. 9 divided by 3 is 3. X to the 4th divided by x squared is x squared. So that happens to be the same, just by chance, not always the way that works. Then we multiply the whole trinomial. Okay, so the whole trinomial by this number up here. So we have 9x to the 4th minus 3x cubed. 6 times 3x squared is going to be plus 18x. So then I put my parentheses around the whole thing, I subtract, and now basically I just have 3 signs to change. So this becomes positive, a negative, a positive, and a negative. First terms always cancel. Negative 21x cubed plus 3x cubed is going to be negative 18x cubed. 12 minus 12x squared, oops, this was a mistake here. This should have been an x squared. So 12x squared minus 18x squared is negative 6x squared, and then we bring down the next term. So back to the beginning. And in some ways, polynomial long division is actually really rote, which means it's just kind of the same process over and over again. So once you get it, it doesn't take as much thinking as some other things in math. I'm going to erase this line though because it looks like division when I get to the next step. So 3x squared goes into negative 18x cubed. Negative 18 divided by 3 is negative 6. And then x cubed divided by x squared is x. So that's what I'm going to multiply by next. So I have negative 18x cubed. Negative x times negative 6x is positive 6x squared. 6 times negative 6x is negative 36x. So now, this is where we have to be pretty careful because it's going to be super tempting to cancel something that doesn't cancel. So this is negative, change our signs. This is going to become a negative, so those two don't cancel when I change that sign. This does, those are opposites. Negative 6x squared minus 6 more x squared is negative 12x squared. Negative 26x plus 36x is positive 10x. And then I'm going to bring down my next number, which is negative 18. So our next step, 3x squared goes into negative 12x squared, negative 4 times. So this is going to be negative 12x squared. Negative 4 times negative x is positive 4x. And 6 times negative 4 is negative 24. So from here, change those signs. So I have 10x minus 4x is 6x. This cancels. Negative 18 plus 24 is positive 6. So yes, you can have a remainder with polynomial long division. That involves a variable in the remainder. So writing my answer in that quotient remainder form, it's called, I have 3x squared minus 6x minus 4 plus, here's my remainder, 6x plus 6 over, here is my divisor, 3x squared minus x plus 6, and that is my final answer.